Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration of exponents. Take note, this is part 10. I encourage you to check out the other parts before this part 10. Let's take a deep dive into what we'll be looking at today. Recall, integration is the reverse of differentiation. That is to say, if we have y is equal to e to the f of x, then to find dy dx, which is the derivative of y, we would get f prime of x times the exponential of f of x. As easy as that. Therefore, meaning that if we are integrating the exponential functions, we would divide with that which we obtained the derivative of f of x, and plus the c, the constant of integration, implying that the integration of e of x dx is e to the x plus c. Also, the integration of e of ax plus b dx would be equal to 1 over a times e to the ax plus b plus c, the constant of integration. And take note, a, b are elements of real numbers. Now, let's take a look at the first example. We are asked to evaluate the integral from 0 to a half of e to the 4x dx. The solution from equation 3, and recall what we had from equation 3. In this case, we have our a is 4 and our b is 0, so we won't include it in this case. Right, implying that the integration of this integral would be 1 over 4 times e to the 4x, and evaluating from 0 to a half. And recall, in our prior videos, we spoke about how to go about integrating definite integrals. So in this case, we are saying that we are going to substitute the upper limit first. That is to say, we would have 1 over 4 times e to the 4 times a half minus 1 over 4 times e to the 4 times 0. Right. So simplifying that, we would get 1/4 times e to the 2 minus 1/4 e to the 0. And with that, simplifying further, we would have 1/4 times e to the 2 minus 1/4. And of course, we are going to factorize so that we have 1/4 times e to the 2 minus 1 as our final answer. Let's go to example 2. So with example 2, we are asked to find the exact area of the region bounded by the curve y is equal to 1 plus e to the 2x minus 5, the x-axis, and the line x is equal to 1 and x is equal to 3. So already here we can see that we have the limits x, 1 and 3. So the lower limit 1, the upper limit 3. And also we would know from equation 3 that for us to find the integral, which is in this case the area, and I encourage you to check out the area videos where we covered area and volume. This would help you indeed. Right, so moving on with our solution. We are saying that from equation 3, this is what we had, and that is what we know. Integrating e to the ax plus b would give us 1 over a times e to the ax plus b. So it means that we have to identify what our a is. So now our a is 2 and our b is minus 5. Then it implies that the area, taking the limits from 1 to 3 of 1 plus e to the 2x minus 5 dx, would be equal to x plus a half times e to the 2x minus 5, and preserving the limits for now, we would have that. Right, moving on. We are going to substitute the limits, starting with the upper limit. That is to say that we are going to have 3 plus half times e to the 2 times 3 minus 5 minus 1 times 1 plus 1 over 2 times e to the 2 times 1 minus 5. We simplify that one further so that we get 2 plus half times e minus half times e to the power minus 3. Simplifying that further, we would get 2 plus a half times e minus e to the power minus 3 square units. That is our final area. Let's look at example 3. So with example 3, we have e to the x cubed, and our solution, we are saying that from equation 1, recall, we have to identify what our f of x is, because we would need to differentiate that. So in this case, our f of x is x cubed, and we know from differentiation that f prime of x is going to be 3x squared. Now, with that, we are going to find the integral of e to the x cubed. So in this case, we just substitute from what we had from equation 1, so that our final answer becomes 1 over 3x squared times e to the x cubed plus c. Let's look at example 4. Evaluate the integral of e to the sine x dx. So for the solution, in this case, we have to identify our f of x from equation 1. So in this case, our f of x is sine of x. Now, if we differentiate that according to differentiation, we are going to get f prime of x, which is cosine of x. Now, we simply substitute this integral of e to the sine x dx into the formula or equation 1 that we highlighted before. Then our answer becomes 1 over cosine of x times e to the sine of x plus the c. Great. So now let's look at the second part of dealing with exponents. We are saying that in general, if you have the integral of a to the x dx, then your answer becomes 1 over ln of a times a to the x plus c. And recall, ln of a is the natural log of a. In this case, we are also saying that a is an element of positive real numbers. Let's look at an example. We have the example, evaluate the integral of 3 to the x dx. Now, we have to identify what our a is from equation 4. So our a is 3. Then it will mean that the integration of 3 to the x dx is equals to 1 over the natural log of 3 times 3 to the x plus the c. If you have made it thus far into the video, congratulations. I'll leave you with the following task. Integrate the integral of 3 to the x minus x pi plus 4 times e to the x squared plus 2 dx. Remember to like, share, and subscribe. Thank you so much for watching Numbers Simplified. God loves you.